So there's some special cases that we have to think about. So let's think about those special cases, okay? So let's think about, there are two lines, right? There's a yellow line and there's a blue line. The yellow line is horizontal and the blue line is vertical. Now we sort of said that the equation of a straight line is of the form y is equal to mx plus c, right? That's what we expect the equation of a straight line. So I'm working on the yellow line right now. Now please note that and we know the formula for m was just equal to y1 minus y2 over x1 minus x2, provided x1 is not equal to x2. So now we can pick any 2 points on the yellow line, right? So I can pick any 2 points on the yellow line. Let me pick maybe a point right over here. So I'm going to pick a point right over here, and then I'm going to pick a point right over here. Now you can see that the y value is not changing. It's constant. It's 2, right? And the x value goes from 0 to 2. So if I try to calculate m, when I calculate m is just going to turn out to be equal to 2 minus 2 over x1 minus x2, which is going to be 0 minus 2, just 0 divided by minus 2, which turns out to be equal to 0. And this is saying that the gradient is 0, right? So that means the equation is just y is equal to c, and from the point 0, 2, you can see that the intercept is, the y-intercept is c, so the equation will turn out to be equal to y is equal to 2, and you can just read it off because clearly the line is a constant at y equal to 2, okay? Now let's think about the blue line. The blue line is slightly different. I can play the same game and assume that y is equal to mx plus c, and then I can say the slope is again equal to my1 minus y2 over x1 minus x2, provided x1 is not equal to x2, right? So let's pick 2 points on the blue line. Let's say I'll pick the point 1, 0, and I'll pick the line point 1, 2. So let me color them slightly differently. Maybe I should use red for these 2 points. So this is 1, 0 and 1, 2. So now if you try to calculate m, well, m is going to turn out to be equal to y1 is going to be equal to 0, and y2 is going to be minus 2 over x1 minus x2. But x1 is 1 and x2 is 1. This is 1 minus 1. And actually, this is equal to minus 2 divided by 0. And this is an illegal operation. This is illegal. You cannot divide by 0 in mathematics. And please remember, we actually stated that x1 cannot be equal to x2. But here x1 is equal to x2, so this is all wrong. We can't do this. So you cannot say that the slope is infinity. What you have to say is that the gradient is undefined. So m is undefined because dividing by 0 is not a legal operation in mathematics. We don't know what it means to divide by 0. But now, if you think about it and forget about this this whole thing, what does it look like? Well, if you look at this line, I'm looking at the blue line. What can you say about the blue line? What is true about the blue line? Well, what is true about the blue line is that x is always a constant at 1. So you can say that the equation of this line is x is equal to 1. Okay? So I just wanted you to understand and appreciate that the horizontal line and the vertical line have two different meanings. For the vertical line, you cannot use the equation m is equal to y1 minus y2 over x1 minus x2 because division by 0 is illegal in mathematics. But for the horizontal line, you can, and the slope is 0 and the gradient is 0. Intuitively, the horizontal line does represent a gradient of 0 because you're walking on flat land. This, some people say, the blue line, some people say is infinite slope or infinite gradient. That's kind of a slightly sloppy way of saying this idea, but they're not completely wrong because what they're saying is imagine another line, right? So I'm just trying to explain to you why do some people call this to be. So imagine a line which is very close to this line, but it's not exactly vertical, okay? They're very close to this line. So if you have a line like this, now you can see that for a small change in x, the change in y is very large. Okay, so this line will have, when you look at the when you look at this line, this m will be very large. M will be large. Okay, so this will be the gradient of this white line will be very large, and it's going to get larger as you start to rotate towards the blue line. So when it becomes to be bigger and bigger and bigger and bigger, people would like to consider the blue line to be infinite, although it is technically incorrect. Okay.